Well, it is time for part 2 of the seamless helmet mold over a halo helmet. This is a 3D printed pattern provided to us by Rhino Props. Now in part 1, I made the silicone mold. This is a seamless silicone jacket that goes over this helmet. And in part 2, I'll be making the resin support shell. Now this particular mold, this is going to have a one-piece silicone mold over the main business part of the helmet, and then a silicone plug on the underside, and a 3-piece resin shell to hold it all together. And the whole idea here is the finished result, the final mold that we'll have at the end of this video, will be used for rotational casting on a rotational casting machine. Hence the little plug or port in the bottom of the mold that will be used for filling this with resin for rotational casting. So every step of this process needs to be working towards that end goal. If you missed the introduction, I'll link it at the end of this video, so be sure to check that out. That will explain a lot of the thinking of why this mold is made the way it is and with the materials that we used. Now, the first order of business as we get into the process of making the resin support shell for this mold is we're going to divide up that silicone mold. Now, obviously, you don't want to demold your helmet before you make your mother mold. Really important. You can never get that back in exactly the way it was. So always make sure that you go straight from the process of making your silicone mold to making your resin support shell or whatever kind of mother mold you're going to make over the part. Now, what I'm doing here is dividing this up into two halves, left and right, and those two halves will be the two halves of that mother mold, the main two parts of it. And I want to make sure that that's divided up so that I can come off straight without any undercuts or any areas where it will drag on that silicone mold and cause problems or get locked up on the part underneath. So bisecting it that way right down the middle of the head is the best way to do that for this part and not have any undercuts. Now what I'm doing here is using some solder to trace the profile of my part to create my splitter board. So I'm taking that solder and unrolling that and putting that down on the profile of my part. And then what that lets me do is transfer that profile to a piece of foam core board and be able to trace out the exact profile, or at least as close as possible to the profile of my part. And then I can cut that profile out on my splitter board, which will be a large piece of foam core board. And then that allows me to create that parting line for that support shell. So you can see there, I've traced that onto that foam core board and cut that out with a razor knife. So now I have my splitter board. Now those gaps between the splitter board and the silicone mold, we're going to fill those in with soft Protolina clay. And Protolina clay is already really soft at room temperature, but it's always a good idea for this kind of work, especially so you can get it to stick to that silicone a little bit better, to warm it up in a microwave just for like 10, 15, maybe 20 seconds. You don't want to do it too long or the clay will start doing some very strange things. Now this is the reverse side. I flip this around and I'm going to reinforce it on the back side using some plaster bandage material. Now this is one of those optional steps, but it definitely helps out a lot because what the plaster bandage material does is stabilize that splitter board so it doesn't try to tip over or scoot around on your mold while you're making the first half of that resin mold. And when you're working with resins, that's the last thing you want to happen. Now, as I've mentioned in previous tutorials, when you're using plaster bandage material like this, make sure that you use the high grade, medical grade, fast set or extra fast set bandages. The hobby grade material will take forever to set up and it will really slow down your process. And the high grade extra fast set is not any more expensive. And in fact, sometimes it's actually cheaper than the hobby store grade. Now, once my bandages have set up, and that usually takes maybe 10-15 minutes, I'm ready to start filling in the rest of that gap between the splitter board and the silicone mold. And again, just softening that clay up with a little bit of heat will really help that smooth out that edge. And what we want is a nice right angle between the splitter board and our silicone mold. Now, once you've filled in that gap, now you're ready to create some keys. And we're just going to do 3 key shapes on that splitter board. And remember that this is going to be a rigid mold, so you've got two rigid halves coming together at that seam. And that means you want to make absolute sure that your keys don't have any undercuts. So that's why I'm doing these little trapezoid shaped keys. So all the different sides are beveled off at a slight angle, and that way I don't have any undercuts that could lock those key shapes together. Now the mother mold is going to be made of BR75D brushable resin, and that is very adhesive. So we want to make sure we release the splitter board, the keys, and the baseboard using Partol high temp wax. Now, Partol high temp wax, like the name implies, has a higher resistance to temperature than some of the other paste waxes out there. So it's ideal for this kind of application where we'll be using a resin that will exotherm. And when it goes to that exotherm state, we don't have to worry about that pushing through that wax and grabbing onto the material underneath. So real important, you want to make sure you apply that paste wax all over the splitter board and the keys and the clay and anything else that the liquid resin will touch when it's in its uncured state, so you don't wind up bonding it to any of those surfaces. And now we're ready to mix up our BR75D. Now BR75D is mixed 1-to-1 by weight. And real important, as it says on that part B, you want to mix that up before you dispense that part B. So make sure you stir the B first before you measure that out. And I typically start with the thicker of the two components, and that way it's easier to match with the part A, which is a lot lower viscosity. Now, when we mix the two components together, they're going to thicken slightly to form a brushable paste. Now, the way it is naturally right out of the kit, you're going to wind up with a paste consistency that's kind of a light paste consistency. And it's ideal for this first coat. I typically do a mother mold like this in at least 2 coats, because this first layer, this has a little bit of a sag to it, and this is perfect for getting in around those key forms and any detailed areas we need to get it into. And then later we're going to come back with another batch that's going to be thickened up with FiberThick to make it a really thick frosting-like consistency. Now, BR75D has a 7 to 8 minute working time at room temperature and a 2 to 3 hour demold at room temperature. And remember, if you're working in a warm environment, that's going to speed it up, and cold environments will slow it down. And you never want to work with a product like this in a work environment that's lower than about 65 degrees. Anything lower than that, you're going to start to wind up with really brittle resin or cure issues. Now, what I'm doing here is just applying this to that flange, and I'm going to create a flange for this mold that goes about 3 to 4 inches outside of the actual part, because I want plenty of room on that flange to run hardware through it later if I need to bolt this together. Now, as I mentioned earlier, when you mix this up right out of the containers, you're going to wind up with a consistency that's thick, but it does run and sag just a little bit. And that's ideal for this coat, where we need to get it into those detailed areas around those little clay key shapes and those little silicone button keys there down at the base of the silicone mold. So real important, we want to make sure we get that nice wide flange on our mold. And what we're going for here overall is about 1/8 of an inch thickness with this first coat. That's about as thick as you can make it before it starts to run off and just form expensive puddles at the base of the piece. Now, when we apply the second coat, we're going to bring it up to around a thickness of about 1/4 of an inch to 3/8 of an inch. And remember that you don't need much more than that. By itself, this is a really strong resin without any reinforcement fiber. Now, what I'm doing here is just using a popsicle stick or a stir stick to clean up that edge and pull that back a little bit and make sure that the base of the mold and that flange is nice and squared off by using a stir stick or a trowel, and just bring that back a little bit and define that edge. And that eliminates a lot of the cleanup work that we have to do later on. Again, the more you can do at this stage when the resin is wet, the less sanding you'll have to do once everything is cured. And now ready for our second batch of resin. Now this time we'll be mixing up our BR75D, and we'll be adding to that some FiberThick thickener. Now, FiberThick can be added since it's inert. There's not a specific amount you have to add or not add. You can add as much or as little as is required to get the consistency you want. So what I'm doing here is I'm adding this a little scoop at a time to get it to a consistency of like frosting. And what I'm looking for is a no sag consistency where I can butter this up on my mold with a trowel or stir stick or popsicle stick or whatever, and I don't have any of that material running down. So one way to test that is use the side of the mixing bucket as you're adding the FiberThick to the material, mix it in, and then pull it up on the side of the bucket and test to see how thick it is. And when it stays up on the side of the bucket, that's a good indicator that you've hit the consistency you need to move forward with the mold. And it's important to remember at this stage that it's not so much how many coats you're applying to make a good mother mold, it's the overall thickness you're going for. Because once you've thickened this up to the consistency of like frosting, obviously you could build this up a ½ inch easily with one coat. But the whole point of this is to make a tough, lightweight mother mold that uses just enough resin to get us a strong mother mold, but not so much that it winds up being unwieldy or cost too much. Now, typically for this second layer, again, your overall thickness you're shooting for is about 1/4 inch to 3/8 inch absolute maximum. Anything more than that is just going to be wasted resin. And I typically apply this layer with a combination of a wide chip brush and a stir stick. You can also use little throwaway popsicle sticks, but just remember the BR75 is very adhesive, so I wouldn't use your nicer tools like steel palette knives or anything like that. And real important to thicken up that flange, the base of the mold and that flange that goes around the top. It's real important to have those nice and thick and sturdy because when this mold is flipped over, it's going to be sitting on that edge. So you want to make sure that's nice and strong and can withstand the pressure of that mold flipped over. Now, this is a very strong resin by itself. This is one of those few resins that even in really thin sections is really strong. So you don't have to put reinforcement fiber in this, but you can add that if you want. There's nothing stopping you from doing that. But just remember, for most applications like what I'm doing here, there's no reason to add fiber to that. And now I'm just going to go back and smooth out the outside of that mold as much as I can because, again, the more of this we can do while the resin is in its wet state, the less sanding we have to do later on. So you want to just smooth that out, get that outside of that mother mold as smooth as possible. And again, just come back along that edge and clean up that flange so that you have a nice squared off edge on the edge of the mold and at the base of the mold at the bottom of that silicone mold. So just come back and repeatedly square off those areas anytime you get drips, and it just makes for a much nicer, cleaner mold. And again, our working time with this is 7 to 8 minutes. So you want to keep track of that. Anytime you're working with a resin system where you're new to the working time, it's a good idea to keep your smartphone handy with a timer for that and just keep an eye on that working time. Now this is about 2 hours later and ready to carefully remove our splitter board and make the second half of the mold. Now remember, with polyurethane resin systems, the thinner the cross section, the longer it's going to take to achieve full cure. So typically this has a 2 to 3 hour demold, but remember, the thinner the cross section, the longer it's going to take for it to set up. So make sure when you're working in really thin sections, you give that extra time to set up completely. Now what I'm doing here is just using a razor knife to cut off any of that excess resin. And I pulled those little key shapes out. If everything was released in accordance with the prophecy, that should all pop right out. And now ready to apply more paste wax. So again, we're using the high temp Partol paste wax, and we're going to apply that all over that baseboard and of course all over that exposed BR75D flange. Now this is where you want to be very careful and very thorough with your application of paste wax. Make sure you get it into those key shapes really well so you don't have any bare spots of resin because, again, that BR75D is really adhesive, so you don't want to risk it sticking to those key shapes or locking up on you. And then, of course, we want to make sure we apply that to the baseboard. And if necessary, you could apply it to the silicone, but typically the silicone will naturally resist that BR75D. Now, super important step here. We're going to build some little pry points into the mold to make it easier to open later on. And here I'm just using a steel spatula to cut that clay off, and I've just rolled out some little snakes of clay. And I'm going to put 3 pry points on this, one on each side and then one at the top. So again, what I'm doing is just making some little snakes, bending that over the edge, And then I just come back with a little palette knife, a little steel palette knife tool, and just chop that off to make it nice and straight on the end. And then we're going to spray some release over those to make sure that it doesn't stick. I'm using a spray release rather than the wax just because it's a little bit easier to apply at this point. So I'm using the E236 spray release to make sure that the resin doesn't stick to those little pry points. And now ready to apply our next layer of resin. Now again, this is using just BR75D with no FiberThick. So it's got that little bit of a run to it, and that will help us get it in there around those little pry points and into those key shapes. And again, brushed in really good with no gaps or air bubbles around those little button keys there at the base of the silicone mold. Now, just like the first half of the mold, we're going to be doing this in 2 layers, and an important detail here is the recoat time between those layers. This has a 7 to 8 minute working time, and then typically about a 20-minute time after that. So about 30 minutes in total from the time you mix up and apply this to the time that you're able to apply another layer of resin. So real important, make sure that the resin has set up enough that you can apply the next layer without disturbing that original layer. And typically that's about 20 to 30 minutes after you've applied that first layer. So again, this is the BR75D thickened to a really thick paste using the FiberThick additive. And that brings it up to that frosting-like consistency. And just like with the previous side, you want to make absolute sure that you're getting that flange nice and thick and the base of the mold nice and thick. Because again, we may be running some hardware through this to bolt the 2 halves together. And we might also be running some hardware through this to mount this on the rotational casting machine. So real important that that outside edge is nice and thick. And one of the ways to check that cross section of your resin shell is to drag your stir stick across the seam and around the base of the mold and pull back a little bit of that resin and make sure it's nice and squared off on that edge. And that will allow you to see what kind of thickness you have built up, especially there at the base of the mold. You can see where I pulled that back a little bit and we have a nice thick mold. Now at this point, if you need to, you can apply more BR75D to the entire mold because now you have the both halves of the mold done. So we're going to mix up another batch of BR75D with FiberThick. So we have that really thick frosting-like consistency. And I'm mainly applying this just on the flange on both sides to make sure that's nice and thick. And then just looking for any thin spots that need to be cleaned up a little bit. But again, this is a purely optional step, just depending on how you're making your mold and how thick you want that finished mold to be. Again, I typically, for a mold like this, I typically shoot for about 1/4 of an inch to 3/8 of an inch overall thickness. And I'm mainly coming back to do this mainly for those seam areas because that's the area I know is going to be taking the most abuse on the finished mold. Now, once this final layer has cured completely, again, typically about 2 to 3 hours, then we are ready to sand on the mold and do any refining we need to before we move to the next step. So here I'm just using a wood rasp to pull back that seam a little bit and clean that up. And watch out for my little clay pry points. But I'm just mainly exposing that seam and checking everything out before we flip this whole assembly over and make the final piece of the mold. The final piece, and you don't need to do this if you're going to be hand rotational casting, but if you're doing something like this, it's going to ultimately go on a machine, you will need a pour spout. So that's what I'm making right here by, I clayed up underneath the helmet, and I'm pressing a wax paper cup into that clay, and that will ultimately be my pour spout. So now I'm just cleaning up that underside of the helmet with clay and making sure that's nice and smooth. All that will ultimately just be a big cutout area in resin later when this is demolded. But I need a nice smooth underside to this. And once that's in place, ready to release that clay and release that exposed silicone with some Zip 301 mold release. And remember, this last piece of the mold, this is basically just a cap, so this will go on a machine and be able to be plugged up with a little piece of silicone. So real important, make sure you release that really well because you'll be going silicone to silicone on this part of the mold. And since the silicone is very fresh, I'm going to brush this on and spray it one more time. So I spray it on, brush it into the detail, and then spray it again one more time. Now for this cap on the mold, I don't need it to capture a lot of detail, so I'm just going to do this in 2 layers. I'm going to use 1 layer of silicone that I just put a little bit of the SC5001 thickener in it, so it still has a little bit of a run to it. And I'm going to brush that out onto that flange really good. And then I'm going to follow that up with 1 more layer of heavily thickened 5130 with even more like 1% of the SC5001 thickening agent in. So here's the second and final layer of silicone. And again, my overall thickness I'm shooting for here is about 3/8 of an inch at the absolute thickest point. And I want to make sure I don't have any undercuts. And again, this mainly serves the purpose of a giant cork on the bottom of the mold. And I've got my little fill port that I can plug that up using a little plug of silicone later on. So once I've got that applied, I'm going to do one last step to this that's a little bit different than the rest of the mold. So hopefully you stuck around for this part, because this is an important little detail. Because this underside of the mold, I want this to all be one piece that sticks together. It doesn't have any undercuts on it. So I'm actually going to bond the silicone to the BR75D resin. Now to do that, you might have seen this in some previous videos where I use some cotton fiber. You could also use cheesecloth in this, but the main thing what you're doing here is creating a fiber linkage between the silicone and the rigid support shell. So I'm just taking some cotton balls and unrolling those and pressing that into that wet silicone. And then once the silicone sets, I go back and pull up that extra cotton fiber. And what that does is I wind up with little fibers stuck in the silicone, sticking up out like little hairs that then will bond to that final resin shell. So this is about an hour or so later. I'm peeling off that remainder of the cotton fiber, that extra cotton fiber. Real important, you want to do that. Otherwise, if you don't pull the excess off, the shell will, and then they'll just go ahead and separate because they're not really grabbing onto each other that well. So real important, pull off that excess cotton fiber. And now ready to apply the BR75D. And just like the other sections of the mother mold, we're going to apply at first just the BR75D by itself, and then we'll follow that up with another layer that's the BR75D along with the FiberThick thickener. And we want this layer to be a little bit on the runny side so we can get it to really saturate that cotton fiber so that the resin really locks into that piece of silicone. And once that gels, we let that sit for about 30 minutes. And we're ready to come back with that final layer of BR75D. Again, this is BR75D thickened with the FiberThick. So now we got that nice frosting-like consistency. Real important at this stage to really keep this nice and square and smooth so that everything fits together nicely and you have a nice smooth surface in case you need to drill into this to add some hardware to bolt this all together. And to make sure you have a nice squared off edge, it's a good idea to come back with your stir stick and go around that edge and square that off with your stir stick or a popsicle stick so you get that nice defined squared off edge where the resin meets that silicone. And that will avoid a lot of chipping and cracking by avoiding a feathered resin edge that winds up being way too thin. So real important, as we're applying that resin, come back occasionally and square off that edge with, again, either a tongue depressor or a stir stick. And that's a good way to gauge your thickness of your mold, and check that out and make sure you have a nice thick mold, especially on this base, because again, this is one of those areas where the mold's going to be flipped over and sitting on this part. So you want it to be nice and tough so it will withstand that in regular casting operations. Okay, so it is now time. This is about 3.5 hours or so later. And you see I did stabilize that with some C-clamps just because I didn't want those two halves coming apart in the middle of this. So I C-clamped that together just to be on the safe side. And now ready to trim back that pour spout. I peeled out that wax paper cup. I'm just going around that with a razor knife to remove any of the excess silicone on that pour spout. And now we are ready to demold our helmet. Now remember those little clay pry points that I created between the two halves of that BR75D mother mold? We're going to use those now. We're going to put a flathead screwdriver in the front and the back pry point, and you could do the top too if necessary. And the reason now, you can see the reason I didn't make those pry points go all the way to the silicone is we don't want to gouge our silicone mold by jamming a pry bar in. So now we're able to peel that off, and there is the first half of the mold taken away. And now we can take off the bottom of the mold, and then we're ready for the other side. Real important at this stage to not get impatient. Make sure you take your time demolding and trimming each piece of the mold. And now we have our finished silicone mold with BR75D mother mold. And of course we have our seamless mold there that we need to peel off our pattern. But we have our 3-piece shell that goes over the top and that cap that fits on the bottom. Now, because this does need to turn inside out, I'm going to powder this with baby powder before I start removing it. And that just helps that silicone move a lot easier over itself. I've got my lovely assistant Chris helping me out here. And this first demold, this is always the trickiest because we still have some little bits of silicone going into that 3D printed pattern. So I'm going to go back and cut those with a scalpel and then peel that off. And there we go. We have our 3D printed helmet ready to mold again if necessary. And now we have our silicone mold ready for casting. So now we can reassemble this whole thing. See, I still have a little bit of trimming to do there on the base, but you see how everything fits together. We got that nice little silicone cap for the bottom, the left and right halves of the mold, and now ready to strap that together or bolt it together and put that on a machine and start casting. And of course we fill in that little port using a plug made with 5110 platinum silicone. Now, as always, all of the materials I used for this video will be linked in the video description, so be sure to check that out. And stick around for the final installment of this series, where I'll be putting this on a machine over at Rhino Props facility and making a rotational resin cast. Now, if for some unholy reason you still haven't subscribed, be sure to subscribe and, of course, click the little bell icon so you get notified when I post new content. And, as always, thanks for watching and supporting the channel.